So the current electricity chapter we've already covered. And as I told you today, we'll be starting with moving charges and magnetism. This is magnetism. Yes. Okay, so when we start with magnetism chapter, the first thing that we have, this is magnetic field of a moving charge. Okay, the whole concept rotates on the magnetic field of moving charge. Now see, when we for calculation of the magnetic field, the law that we apply is the Biot-Savart law. Okay, Biot-Savart law. So the formula of Biot-Savart law we've already done in our regular class. And what all things, it depends on the whole detailings. Mu naught I dl sin theta divided by 4 pi r square. So this is the whole Biot-Savart law. Now there can be different forms in which this law can be used. The same formula can be used. One of the formula, this is one formula. Second formula is B is equal to mu naught by 4 pi. Okay, Q V cross R divided by R whole cube. Because this is given in the vector form. In the vector form, when you write this law will also be mu naught I dl cross R divided by 4 pi R cube. This will be in the vector form. Similarly, this is also in its vector form. One more formula, see, one more. If when you open it or expand it, when you have to use it. So for using this, you can simply write B is equal to mu naught Q VR sin theta divided by 4 pi R cube. Okay, this is what you can write when you open up the bracket. Or what you can do in order to remember it, and when you are solving for the NEET paper, you can avoid the R also. You can simply write V sin theta divided by R square. That will also be correct. Okay, that is your Biot-Savart law. And see, basically mu naught, when we talk about this mu naught, you already know it's the constant, permeability constant that comes in magnetic field. So we had epsilon naught in case of electrostatics. Now we have mu naught. So mu naught is the permeability of free space, whose value is 4 pi into 10 to the power minus 7. This is the value of this permeability. Okay. So magnetic field SI unit. What is the magnetic field SI unit? Jasleen?
Tesla.
Tesla. Yes, very good. This is Tesla. And see, when we talk about the magnetic field, one more unit you can write from magnetic flux. That is Weber per meter square. Okay, so this is something which we didn't discuss. Quickly note this down and let's see some more things based on this chapter. Okay. Done with me till here?
Yes, ma'am.
Okay. Now see, coming to the different applications of Biot. When we talk about the different applications of Biot law. Okay. So applications, we've already talked about, there are various kinds of figures that are present. So quickly we'll discuss. But one of them is very important because that we haven't discussed yet. When we have a finite straight wire, its magnetic field. We didn't discuss that. We always had the magnetic field due to the circle, the infinitely long wire, semi-infinite wire and all. We didn't have the magnetic field due to the long wire, due to finite wire. So this is a finite wire. And let's say a wire is there. This is the midpoint of the wire. And the magnetic field that you are calculating is at its midpoint. Let's say at this P point, we are trying to find out the magnetic field. Now, since this is finite, this separation, this part is L by 2, this is L by 2, means total separation, total length of the wire was N. So from the midpoint, we are trying to find out what's the magnetic field at this point. Okay. Now, what we do, the actual formula for this is the magnetic field is given by mu naught I by 4 pi r, where capital R is this, that is your position vector. I is the current that is flowing across the wire. So mu naught I by 4 pi r sine alpha plus sine beta. This is the formula, sine alpha plus sine beta. So what we do, what is the sine alpha and what is the sine beta? Basically, we take up the values from this point. This is the P point. So this angle that the P point is making with one of the ends of the wire, this is taken as alpha, while this angle is taken as beta. This is a general formula, okay, for any finite wire. So for that, you should know the values of alpha and beta. So alpha and beta, they are angles present. So these values you should know by yourself. Now see if in the same formula, using this formula, if I try to make it infinite, if I try to make this wire as infinitely long wire, same thing, it means that this is extending up to infinity, this is also extending up to infinity. This is the second case where I have taken infinite wire. Now look here again from the midpoint, this is L by 2, this is L by 2. The total length is L. So from the midpoint, we are taking a point. Let's say this is a point P here. Like the previous question, here also we are taking a point that is P. And we have to find out the edges. Here, P. This would be your alpha, and this will be your beta. Now, in infinite, what happens is from this infinity end, if you take this point and join, infinity means this is something which is extending up to infinity. Infinity, it means extending, extending, extending. So if everything is extending up to infinity, it means this is so huge, right? If it's like you extend it and extend it. Something is at infinity. This is extending up to infinity, and you're trying to catch up the last point. Will you be able to catch it at infinity? It is not possible because where will you meet? There is no end which you know. It's not a very long distance that I tell you 1,000 meters or something, that this length or something. It's very difficult. Okay. So infinitely long wire, the infinity, you're trying to as if make up the angle. Ultimately, what will happen? If this won't meet infinity, eventually this will become like this. So your alpha, values of alpha and values of beta, it will be 90 degree. Okay. The value of alpha will be equal to value of beta, that will be equal to 90 degrees. So here when you put the formula, magnetic field is equal to mu naught I by 4 pi r into sine 90 plus sine 90. Now, what is sine 90, Jasleen? Yes, answer.
Sorry, ma'am.
How much?
Ma'am, can you repeat? Sine 90?
Sine 90. I'm asking you what is sine
1.
90? 1. Are you not listening, Jasleen?
Ma'am, I am.
Okay. So see, this is V is equal to mu naught I by 4 pi r. This becomes 1 plus 1. That is mu naught I by 4 pi r into 2. That's why we have the formula of magnetic field as B is equal to mu naught I by 2 pi r for an infinitely long wire. Okay, so that's how we write for infinite. And see, same thing if I take for semi-infinite. Let me take a third case. This is semi-infinite. So this part is there and this part is extending up to infinity. Means this is fixed and the point lies near the infinite end. So this is the third case, that is semi-infinite wire. Okay, this is semi-infinite wire. Now here also you will have alpha. This point will be extending up to, this is alpha, and there would be beta also existing. And this is your point P where you have to calculate. Now see, here we are applying B is equal to same formula mu naught I divided by 4 pi r sine alpha plus sine beta. Now tell me, Justine, what is the value of alpha here? What did I discuss with you? Value of alpha.
Ma'am, 90, no?
90 degree, correct. And what do you think is the value of beta? Alpha, you're right. This is equal to 90 degree. Alpha is equal to 90 degree. What do you think is the value of beta? Alpha is right. Is beta making any angle? See, beta, whatever
No.
this beta was, this already got coincided. So this is 0 degree. And sine 0 is 0. So B is equal to mu naught I divided by 4 pi r into sine 90 degree plus sine 0 degree. That makes it B is equal to mu naught I divided by 4 pi r. Like this, you will get random questions. These were the ones which you already knew. You will get random questions also. Please write down this much. Okay, there's one more special case which we discussed. I think we haven't discussed before. One is your related to your semi-infinite wire. Now see, here alpha and beta we could figure. What if I give a point a little lower than where it is expected? Like this is the wire, and the point that I give is somewhere here. This is your point. Now look, your alpha would be this. How will you identify your alpha and beta in this? Okay, so this angle, this is just the subtension of the wire. So here we will extend it and check where is it exactly lying. Now see, this angle will be our beta, and this total angle, whatever it is given, this total angle will be considered as alpha. Now the formula of this. Formula is C. This is similar to what we've studied for a straight wire. For a straight wire that we've studied, finite wire, it will be mu naught I by 4 pi r. Now the difference will be, it will be sine alpha minus sine beta. In the finite wire, what did we do? We took sine alpha plus sine beta. This will be sine alpha minus sine beta. Now, coming to the basic circles that we have, this is the fifth one. Center of a circular loop. Center of a circular loop. So we know this is a complete circle with its center. So here the magnetic field, let's say some radius r is present, and current that is flowing is I. So at the center, magnetic field is given by B is equal to mu naught I by 2R. And if we take this as a semicircle, sixth point, if we take this as a semicircle, like this, I current with a radius. So magnetic field would be B is equal to mu naught I by 4R for a semicircle. And we also discussed if we have this, we already done this part. We have already done it in the class for a center circular arc, which is subtending an angle alpha. Radius is r, and current that is flowing is I. Justine, what is the formula for this? This magnetic field. What is the formula of this? B is equal to mu naught I alpha divided by 4 pi r. This is the formula, and this is there in your CBSE as well. More shapes I'll discuss with you. Please continue writing from here.
Done, ma'am.
All right. So there is one more case. If we have a quarter of an hour, okay, like this, if we have the quarter of an hour. So this is the part that is available where current flows. Let's say here the current I flows, while this part is the radius. Okay, this part is the radius. So magnetic field will be equal to B is equal to mu naught I divided by 8R. So you need to remember this value as it is, directly remember it. Rest of the values, rest of the direction will be given by the right hand thumb rule. Okay, one more case we discussed at the axis, of the circular loop. So when we talk about the axis of the circular loop, if we talk about the axis, so we have the axis as x, and let's say the radius is capital R, and the current moving is I. So this is equal to B is equal to mu naught I capital R square divided by 2 capital R square plus x square to the power 3 by 2. That's the axis. Now, there's one more thing. One question has come in the exam to plot the graph for the same thing. Okay. So, how will you plot the graph for the same circular wire? Means, how is it varying with the axis? So, see, this is the magnetic field versus this is the axis, that is the x. So, this is how you will the okay. This is how you will get the graph. So this graph is for just this above case only. So remember that. Write down the same case. Then we'll discuss.
Ma'am, can you scroll?
Hey, stop writing. Let's discuss this, then you can write. This question says the magnetic field at the center of a circular coil of radius r. Jaslina, my voice is it audible to you?
Yes, ma'am.
Okay. At the center of a circular coil of radius r, due to current I flowing through it is B. The magnetic field at a point along the axis at a distance r by 2 from the center is, and the 4 points are given. 4 values are given. See, first it says that magnetic field at the center of the circular coil. Now, center of the circular coil, it is mu naught. When we talk about the center of the circular coil, that is mu naught I divided by 2r. Okay. Then it says at the axis at a distance of r by 2 means the value of x is given as r by 2. And what's the formula at the axis? It is mu naught I r square divided by 2r square plus x square. So in place of this, if x is r by 2, x square would be equal to r square by 4. Now look, this will be equal to mu naught r square by 2 r square plus r square by 4, because this is x square. Now see, when you put in the value 4r square plus r square, that is 5r square, and 4 goes up. Okay. So this we can write as, this is equal to mu naught I r square into 4 divided by 2 into 5r square. Right, r square gets cancelled. This is equal to mu naught I by 2. This is equal to mu naught I by 2r. Oh, let's do one thing. Let's keep 1r. Okay, otherwise, if we don't keep 1r, this will be cancelled. This is 3 by 2 also, no? So 3 by 2 also let me put directly here itself. Otherwise, r will be cancelled if I don't put it here. This will be equal to mu naught I r square 4. Okay, this 4 goes up. Or in fact, let's keep this 4 also here. This will make this 2 into 5r square divided by 4 to the power 3 by 2. Look, 5 by 4 to the power 3 by 2. This is written as root 5 divided by 2 whole cube. So what will be our answer when you take the ratio from here? Mu naught I by 2r into, we can write this whole thing as 2 by 5, 2 by root 5 whole cube. Now look, mu naught I by r. What is this term? This is the magnetic field at the center of the circular coil, which was equal to B. So which is our option correct? Yes, Jesslyn, tell me which option is right according to you out of ABCD. Which option? Option C would be there. Write it.